Okay, so hello again for a 1216. Okay, so that's 4. So before we were 20, I guess, or 18. Anyway, so hello. So let me just check if you guys are already in front of your monitor or smartphone. So just give me a thumbs up. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so almost half, 60% or 70%. Okay, so do you guys have a question so far regarding with this one? So are we clear on how did we get the result of 3732 base A? Okay, so 3 out of 17, 4 out of 17, 5, 6, 7. Okay, good. So again, don't be shy to ask if ever that you're confused into into this part or that part. Okay, so I'm willing to help. Okay, I won't get angry. Okay, that's okay if you didn't understand it. It's part of learning. So the next one right here is still 2010, but it's now asking us to convert this one to hexadecimal. So before we have a divisor of 8, but of course since we now have hexadecimal, so we now have a divisor of 16. So again, just use your calculator. 2010 divided by 16 will give us a result of 125.625. So 125 for the whole number, and then 0.625 times 16 is for the remainder we're in. It's 10, so you can actually convert this one already. So 10 is equal to A in hexadecimal. So moving on, since this one is still not yet 0, so 125 divided by 16 will give us a result of 7.8125. So 7 for the integer quotient, and then 0.8125 times 16, which is equal to 13 for our remainder. Okay, wherein 13 is letter D in hexadecimal, and then 7 divided by 16 is cannot be. So again, just put here 0, and then whatever is the final number in the integer quotient, just put it as our remainder. Okay, so yeah, once this one's already 0, then you can read the remainder part from bottom to top. So this one is 7b8 base 16. So let me know if you already understand this one. Okay, great. All right, so see, everything in midterm is super easy. Okay, so I would say that this is already the hardest part, you know, especially if you didn't really try to understand what's happening on the module 4. Well, for the rest, let's say module 1, 2, 3, 5, and then 6. So you can, number 6 is also need time to be studied. Okay, but for module 1, 2, and 3, and then 5, so they just need common sense, especially if you're a computer literate. Okay, well, I'm pretty sure that most of you, loves playing. So most of them, you already know them. Okay, but before, like at the year 2010, 1990s, so most of the people needs to learn the basics. But right now, just by exploring the things in front of your computer, you are already learning the basics. Okay. All right, so that's it for the letter D. Let's now move on to the letter E. So convert 2010 base 10 to base 12. So again, the only one that differs is the divisor. So the same process, 2010 divided by 12 will give you 167, and then the remainder or the fraction part, you have to multiply that one to our divisor. You will get 6. 167 divided by 12 is 13, and then whatever is the fraction part or the decimal part, just multiply that one to 12, and then you will get 11, and then convert this one already into letter B. Okay, and then 13 divided by 12 is 1, remainder 1, and 1 divided by 12 is cannot be. So just put here 0. And then since this one is already 0, then you can read this one from bottom to top. Okay, and then whatever is the final number on the integer quotient, just put it right here on the remainder. Okay, so our answer right here is 11b6 base 12. So please verify and then let me know if the answer right here is correct or no. Okay, okay, very good. Miss Jaline Damasulab. Correct, sir. Okay, great. So, in here, as long as you know the process, okay, you can verify this one later on. Okay, just in case that you wasn't able to understand this certain item, then as long as you know the fundamentals, then you can always go back to that specific number and then verify that one again if it's correct or no. Okay, and then here is another, self-study exercises. So again, supposedly if we are in a face-to-face method, we're going to do this one in a one half sheet of paper. But since we are in ODL and then there's too much to do, okay, so I'll only give you guys one quiz, okay, one quiz per module, and then the rest is now your free time to finish your laboratories. Okay, so again, just do this one on a clean sheet of paper, and then if you want me to check your work, if you're not sure if it's correct or no, then just send me a message. Okay, just take a picture and then send it to me. Then I'll verify it for you. Okay, so the next topic right here is conversion of decimal fractions to another basis. So before we have a decimal only, wherein it's a whole number decimal, but in here we now have a decimal fraction, or it's literally has a fraction part. Okay, so here are the steps. So repeatedly multiply the given decimal fraction by the base. Like for example, you want to convert it to decimal, or I mean binary. So just multiply that one by 2. If you want to convert this 1 to octal, then just multiply that 1 to 8. You want to convert that 1 to hexadecimal, then just multiply that 1 to 16. Okay? Depending on the you want that to convert it into. Okay? So that will be your multiplier. And then separate the product's integer from its fractional part and then record the product's integer. And then if the product's fractional part is already 0, write all the tallied product integers by reading them in downward direction. Okay, so again, we cannot dissect this one by one. So the best way for you to understand this one real quick is by having an actual example. So let's have this example number 1 when it comes to decimal fractions, so binary. So convert 0.625 base 10 to binary. So it wanted us to convert this one to a binary. So our multiplier now is 2. Okay, so just get this one 0.625 times 2. Okay, and then separate the results into 2. So the first one is integer and then the other one is fraction. So 0.625 is 1.25, so just separate them literally. So 1 right here and then 0.25 right here, and then the one that you need to get is the fraction part. Okay, not the integer one. Okay, it's the fraction part. So 0.25 times 2 will give us 0.5. So 0 for the integer and then 0.5 for the fraction. And then 0.5 times 2 is 1. And then 0 now for the fraction. So the only time that you will stop multiplying is once you've got a value of 0 on the fraction part. So in here, it's already 0, so you can stop multiplying. And then you can read the result from top to bottom on the integer part. So it's 1, 0, 1. But since we're talking about decimal fraction, so you have to make this one as a decimal. So the final answer is 0.101. Okay? Okay, so just wait a second, guys. Okay, so sorry for that. So are we clear so far regarding with this example, decimal fraction to a binary? Okay, so again, if ever that you have a question, so feel free to ask me right away, okay? Okay, so that's it for this decimal fraction. So let's now have the second example. So again, it is still a fraction, so 0.6875, and then it is still asking us to convert this one to binary. So our multiplier is still 2. So 0.6875 times 2 will give us 1.3750. So with this one, you can just simply use your calculator, okay, to avoid incorrect answer. So 1 for the integer and then 0.375 for the fraction, okay? And then just get this one, 0.375 times 2, you'll get 0.75. So 0 for the integer and then 75 or 0.75 for the fraction. So just get this one again, 0.75 times 2 will give you 1.5, so 1 for the integer and then zero point 0.5 for the fraction. So zero point 0.5 times 2 is 1, okay? And then 0 now for the fraction. So actually, there's already a, you already know that this is already the last one that you have to multiply because 0.5 times 2 is already equal to 1 and then the fraction part is already 0. So it's like, an indicator that this is already the final multiplication part that you need to do. So once this one is already 0, then you can read the integer part from top to bottom. So 1011 base 2. Okay, so correction with this one should not exist. So it's 0.6875. So are we clear so far? Did you guys get the idea or the logic? Okay, great. So 5 out of 18. 6, 7. Okay, great. So another example is, of course, another decimal fraction, but of course, it's now asking us to an octal. So before it's just a binary, but our multiplier now is 8. Okay, so 0.359375 times 8 will give us 2.875. So 2 for the integer product and then 0.875 for the fraction. Okay, so just get this one again, 0.875 times 8 will give us exactly 7. So once this one is already 0, then you can now stop multiplying. So the final answer for this one is 27 base 8 or 0.27 base 8. So please check using your calculator whether this one is correct or no. Okay, very good, Mr. Kiwas. Very good, Mr. Christopher, and then Mr. Kiano. Mr. Kiano, how are you related to Sir Austria, the Dean of, yeah, CTE ba yun? Teacher Education? Kaapelyido lang. I thought he was your maybe uncle or maybe even father. Who knows, right? Okay, so if everything is very good with example number 3, then let's now move on to the next one wherein it is now the complete version of a whole number and a decimal fraction. So this is a decimal whole number and then a decimal fraction. Okay, so it wants us to convert this one into hexadecimal. So that's pretty easy. Okay, so you can actually do this one in two parts. So the first one is for the whole number only, and then the second one is for the fraction part only. So we cannot combine them as one since those two have different process. Okay, so in here we're getting the remainder, but in here we're getting the integer part. So that's why we have to separate those two. So 3023 for the whole number, and then 0.3203125 for the fraction part. Okay, so as long as you know the process for the whole number, then you're good to go. So in here, for the whole number, so it will be a divisor. Okay, so divisor, which is hexadecimal, so 16. But for the decimal fraction, it would be a multiplier, okay, which is times 16. So it's one major difference when it comes to solving a whole number versus a decimal fraction. Okay, so in here, 3023 divided by 16 will give us 188 point something. So that point something must be multiplied with 16, and then you will get 15. Okay, and then just convert that one to F right away. And then 188 divided by 16 will give you 11 point something. So that something must be multiplied to the 16, and then you will get 12. And then you can convert this one already right away into C. Okay, and then 11 divided by 16 is cannot be. So you have to put this one here now is 0, and then whatever is the final number right here will be now your final remainder. Then you can now convert this 11 into B, and then you can now read this one from bottom to top. So the final answer for the whole number is BCF. So just keep it for now, and then you can now move on and start answering the fraction part. So 0.3203125 times 16. Okay, so again, it's now a multiplier since that's the process that we need to do when it comes to decimal fraction. So you will get here 5.125. So just separate those two results. So 5 for the integer part, and then 0.125 for the fraction part. So just to get this one again, 0.125 times 16, you'll get exactly 2. Okay, remainder 0, or fraction part 0 rather, not remainder. So once this one is already 0, then you can now start reading the integer part from top to bottom. So it's 0.52. Then you can now combine them as 1. BCF that 52. So I'll give you guys 30 seconds to 1 minute to analyze this one, and then just let me know once you already got this one. All right, very good. Okay, so 5, 6, I think 6 out of 18. We're already able to get this one. Okay, that's actually it for the decimal. So more exercises that you might want to do to practice on how to convert a integer and then decimal fraction into a binary, base 4 or base 12. So the same with this one, to base 5 to base 15, and so on and so forth. Okay, and then again, just send me a message. Okay, there is a question. So paano ulit nakuha yung 15, sir? Where is the 15? This one right here? This is the one that you're talking about? 15? Okay, so 3023 divided by 16. Just put this one on your calculator. Okay, and then you will get 188 point something, right? And then just multiply that something, okay, to 16. And then you will get 15. So 3023 divided by 16. In my calculator, I've got a result of 188.9375. Okay, so 0.9375 times 16 will give us a result of 15. Yeah, that's it. So thank you, Mr. Kiwas. Okay, so the same with the other remainder right here. And then for your question, Mr. Kiano, sir, sa Canvas po ba magsasend ng message if magpapacheck ng solution? Yes, so you can message me either to my Canvas or to my Facebook account. Okay, so either of those two. Okay, just attach the image. Okay. Any other question? All right. So was I able to answer your question, Mr. Kiano? Okay. All right, so let's now move on to the summary on what are things that you can do to this bases. So decimal can be converted to n base, n base can be converted to decimal, decimal can be converted to binary, binary can be converted to decimal, and so on and so forth. Okay. So in here, let's now talk about hexadecimal to binary conversion. So, this one is actually the first topic that we had. So going back right here, it's just the opposite of that one. Okay, binary and then decimal. But we can also do the binary to decimal. Okay, as long as you know the logic on how to, evaluate the decimal into a binary, then you're good to go with this next topic. Okay, so 0, 0, 0 is equal to 0, of course, and then 0, 0, 0, 1 is equal to 1. Okay, and then 1, 1, 1, 1 is equal to f or equal to 15. Okay, but take note when it comes to converting a hexadecimal to binary, you have to represent each hex digit to 4 binary bits, meaning you have to separate them by 4 bit. Okay, one character is 4 bit, another character is 4 bit, another character is 4 bit. Now, for you to be able to understand this one, let's have an actual example. So this character is 4 bit, another character which is F is 4 bit, another character is 4 bit, another character is 4 bit. So if we have 4 characters, then just multiply that one by 4, and then that's the total bit number that you will have as your final answer. So 4 times 4 is 16. So if you're going to count this one, we have 16 characters. Okay. So to start with, you can start either on the left side or on the right side. Okay, so you can start here if you want. Okay, or you can start here if you want. So either of those two. So the representation of 5 is 0, 1, 0, 1. So you need the 4 and 1 for that one. And then F is 1, 1, 1, 1. And then A is 10. So you need 8 and then the 2. And then for the 1, so it's 0, 0, 0, 1. So you can already answer, you can already have this one as your final answer, but you can reduce this one by removing the other 3 zeros right here because, since we're talking about binary, it will not affect the result of your answer. Okay, since we are reading this one from the lowest bit to the highest bit. Okay, so this one is the first character, if it's on the right, second, third, and then fourth. Okay, and then don't forget to put the base. So are we clear so far? Did you guys able to get this one? The number one? Okay. Alright, so great. So the same thing if we have a decimal, okay, decimal or fraction part. So just separate them still, every 4 bit or every character. So 4 bit, 4 bit, 4 bit, 4 bit. All in all, you have a total of 16 bits right here. So D is 1101. So A, B, C, D. So it's 9 plus 4, so it's 13. So you need 13 right here. So 8 plus 4 plus 1. So 1101 is 13 or equal to letter D. So 6 is 4 plus 2. So 0110. And then 0 is, of course, just 0. And then 3 is 0011. Then again, you can remove this other 20 for you to have this shorter answer. Then wherever is that decimal, just put it right here to represent that this is the whole number and then this is the fraction number. So clear on example number 2? Okay. All right, so great. More and more is now able to understand this topic. Okay, but what about binary to hexadecimal? So if you can do hexadecimal to binary, of course you can do the other way around. So binary to hexadecimal. So still, you have to group this binary to 4-bit to avoid confusion. So this is the original given number. So just separate them every 4-bit. So starting from the lowest bit going to the highest bit. So starting from here, so 4 characters, which is already this one, and then the dot or the decimal point, and then another 4 characters, which is this one, another 4 characters, which is this one, and then another 4 characters, which is this one, and then 1 1, and then 1 1. So for formality's sake, just add 2 zeros again. Okay, so those two are just the same. So 0011, just to represent that this one is in a 4-bit group. Then after that, they can now, get the individual results of those binary combinations. So 2 plus 1 is 3, 8 plus 1 is 9, 4 plus 1 is 5, 4 plus 1 is 5, and then 8 plus 4 plus 1 is 13, which is equal to letter D. So as a result, this is now the hexadecimal number or output. So 3955.D day 16. So again, just give me a thumbs up if everything is clear, and then just ask a question right away if you're quite confused. Okay, great. So dumadami na ang nakakakuha. So very good. Next one, we also have octal to binary. Okay, however, the difference of hexadecimal versus octal. Hexadecimal must be grouped by 4. Okay, while in octal, okay, you must group them by 3-bit. Okay, why? That's because, in hexadecimal, you need 4 bits for you to be able to form the whole set of 1 to 15. Okay, so starting from, let's say, 0, okay, going to 15. So this 0 right here is represented by 000, and then going to 15, you need 1111. So as you guys can see, you need 4 bit for that. But for the octal, okay, so it's being represented by 0 to 7. And 0 is 000, so you need 3 bit only. And then 111 for 7. So as you can see, you don't need 4 bit on this one. Okay, you don't need to say 000 or 01111. Okay, you can have only up to 3 bit. So what happen if you're going to exceed to 1? Let's say uh, you have the other one here as 0 to 0 to, let's say, 10. Okay, and that one is now 0. Zero. Yeah, n base kasi ito eh. So wala tayong pangalan. Call this one n base. N base of 10 na lang. Okay, to make it more easier to understand. And then n base 10, okay, is 0 to 9. Okay, so in here you need 4 characters. That's because we need to represent this 9 right here. Okay, this 9 right here using a 4 characters. So 8 and then 1. Okay, so it's 1001. Okay, unlike in Octal, you only need up to 3 bit. Okay, so 111 is already equal to 7. So 4 plus 3 plus 1. 4 plus 2 plus 1 rather. Okay, so are we clear so far on why do we have 4 bits in hexadecimal, and then why we only need 3 bits for the octal, and then why we need, let's say, 4 bit if it's already exceeding octal, let's say base 9, base 10, base 11, base 12, and so on and so forth. Okay. Okay, so again, that's the reason why we have to group this one every 3-bit only. So 3-bit, 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 and then 3-bit. So 5 is 101, 7 is 111, and then 1 is 001. Then again, you can remove this 20 to have a shorter answer. And then don't forget the base 2. So it's an indicator that I have already converted this octal into a binary. Okay, so did you guys get this one so far? Octal to binary? Okay, great. All right, so let's now move on to the next one. So if we can do octal to binary, of course, we can do the other way around. Binary to octal conversion. So of course, we'll be given this as original combination of binary. But since we're asking to convert this one to octal, so again, you have to group this one by 3. Okay, so if you're going to group this one by 4, then you are already getting the incorrect answer. Okay, so don't forget that in octal, it should be grouped by 3 bit only, or every 3 bit. So 101, 101, 011, 011, 101, 101, 010, 010, 001, 001, and then 11 or 011. Okay, then after that, you can now get the specific result of those each 3 bit. So starting from here, we have 4 plus 1 is 5, 2 plus 1 is 3, 4 plus 1 is 5, and then 2, and then 1, and then 3. So 2 plus 1 is 3. Then wherever is the decimal point, then just place it in there. So you'll get a result of 3125.35 base 8. So clear? Okay, very good. All right, so here's the summary wherein you can convert decimal to NBs, etc., etc. So yeah, just read this one. So there are things that you cannot convert right away. Like for example, where is that one? Here. So you cannot convert octal to n base right away. Okay. So for you to be able to get the n base, so you have to do double conversion. Like for example, octal going to decimal, and then decimal going to n base. So you can also do the other thing. Let's say octal to binary, then binary to decimal going to n base. So you can have triple conversion, quadruple conversion if you wanted to. Okay, for double conversion. Okay, but there are things that you can convert right away, like decimal to octal, octal to binary, hexadecimal to binary, and so on and so forth. But there are things, again, that you need to have a double conversion or triple conversion. Okay, so again, just and more activities. Okay, supposedly this will be your assignment, but since we are an ODL, so you don't need to do this one anymore. Well, if you want to, have some practice exercises, you can include this one. Again, you can send your solution on the my canvas for me to check whether your uh, answers are correct right now. Okay, so the next one right here is operations on numbers. But since we don't have enough time anymore, so we'll just continue this one tomorrow. Okay, we'll finish the remaining slides, so 41 to 63 tomorrow. Okay, so the same time, 8 a.m. up to maybe two meetings only. So part one and part two. So depending on how fast we can finish the remaining topics. So for now, that's it. And if ever that you have a question, so feel free to message me anytime. Okay. Well, if you have a question now, please ask that question of yours now, since we still have 2 minutes left. Maybe we can, uh, find a remedy on that question of yours right now. So no question. Okay, so just give me a thumbs up if everything is already good. You were able to understand everything. Okay, great. Okay, so I need your feedback, guys. So, uh, in, is my pace just fine, or am I too fast? Is it the right pace, or you guys need to, or you wanted to have a slower pace of discussion? Okay, so coming from Mr. Giano, sakto lang daw. Okay, so if you guys would like to have a slower pace, so let me know. Okay, since I think, yeah, in my case, that's how I explain things basically. So it's quite fast, but as long as you guys were able to understand how I explain things, then I guess no problem with that. Okay, so if you guys don't have a question anymore, then you may now go. Let's just meet again tomorrow. Okay, so don't forget to answer now the quizzes, the module 1, module 2, and then module 3. Okay, so goodbye and thank you guys for coming.
Goodbye and thank you, sir.
Goodbye and thank you too. Thank you too. Thank you too. Okay, thank you too.